Hello again, Math 10Cs. In today's lesson, we're going to wrap up the unit of study on equations of linear relations. And we're going to do that by looking at slope as a rate of change. So we're going to look at some word type problems. Okay, so that's kind of like we're going to start with. All the different warm-ups are going to deal with like a word problem type scenario. So the first one says the graph shown represents the distance traveled by a car as a linear function of time. Okay. So it says complete the following to calculate the slope of the line. Okay, so if we go over to the graph here, we can label, we're going to use these 2 points to identify what the slope is. So we're going to say this is point x1, this is y1, this is point x2, that's point y2. And what I'm going to do is I'm going to sub the numbers into the equation, but I'm also going to sub in the units of measurement. So for my y-axis, my units of measurement would be kilometers. So my y values are going to have like units of kilometers beside them. My x-axis is going to have units of hours. I'll abbreviate hours with h. So if we go ahead and calculate this, y2 is 120. We're going to add the units here. Whoops. Let's go back here. Okay, y2 is 120 kilometers. And then we're going to subtract y1, which is 40 kilometers. And the units for distance are in kilometers. And then we're going to divide this by x2, which is 3 hours. And then subtract x1, which is 1 hour. So if I subtract these, I would get 120 minus 40 is 80 kilometers. And then 3 hours minus 1 hour would just be 2 hours. And then if we just calculate this, okay, we're going to do it in 2 parts. First of all, let's take the numbers and divide them. So 80 divided by 2 would give you 40. And then look at the units as well. So the units, kilometers and hours, those are distinct units. They would not cancel each other off. So what I would just do for the units is write it as a fraction. So write down kilometers per hour. B says the slope represents a rate of change, which is a change in distance divided by a change in time. And then complete the following statement by choosing the correct alternative and filling in the blank. It says the distance is, well, what's happening to the distance the car is covering from start to finish? It's clearly increasing. And it's increasing at a rate of what? Well, by calculating the slope actually told me a rate of change. It told me the rate at which a specific distance is being covered over a certain amount of time. So the rate here would be 40 kilometers per hour. So what that means is in 1 hour, I don't know if it's a car. It is a car. Yeah, the car would cover only 40 kilometers. So that's a pretty slow speed. Okay, let's go to warm-up number 2. The graph shown represents the temperature of an oven as a linear function of time. And we want to calculate the slope of this line. So once again, let's just go over here and we're going to use these points on the line to determine that. So let's call this x1, and we'll call this one y1. We'll call this x2, and we'll call that y2. And now to calculate the slope of the line, we use the slope formula because we have 2 points. So we'd have m would be equal to y2 minus y1 divided by x2 subtract x1. And this would be equal to, now once again, we're going to include our units here. So for the y-axis, the units are degrees Fahrenheit. And for the x-axis, my units are going to be minutes. So let's plug the numbers in with the units. So y2 would be a value of 350 degrees Fahrenheit. Subtract y1, which is going to be 50 degrees Fahrenheit. And then we divide this all by x2, which is 5 minutes, minus x1, which is 0. If a quantity is 0, you don't actually have to put the units beside it. So this would give me 350 minus 50 would be 300 degrees Fahrenheit. And then we divide this by 5 minutes. And then I would have the slope would be equal to, do it in two parts. So we take the numbers and divide them. So 300 divides evenly into 5. It's going to give you 60. And then divide the units separately. So the units, you have degrees Fahrenheit divided by minutes. And again, those are two distinct units, so they don't in any way cancel each other off. So I'm just going to write down the units as a fraction. So this would be degrees Fahrenheit per minute. Slope represents a rate of change. So in this case right here, the rate of change is the amount that your temperature is changing over a specific amount of time. And then what are the units represent this rate of change? Well, we determined that by calculating the slope. So the units would be degrees Fahrenheit per minute. And then it says what's happening to the temperature. Well, again, I can see from like start to finish, the temperature is going up, so it'd be increasing at a rate of 60 degrees Fahrenheit per minute, which just means that for every minute of heating, the oven temperature goes up by 60 degrees Fahrenheit. So that's how much the temperature is changing by for every single minute. That's what we call a rate of change. So in this example, it's showing how the temperature changes per minute. And then up here, this was showing how the distance changed where you're per unit time, where the per unit time measurement is going to be in hours. Okay, next page. We've got another example here. Okay, it says the graph shown represents the amount of fuel in the gas tank of a car as a function of distance traveled. Now, they actually have the units written incorrectly on the graph here, so let's fix this. So it says distance in kilometers. Well, distance, D would be the variable that's being used to represent distance. Okay, so I could write down like comma D, but the units are kilometers. Okay, so I'll put the units in brackets here. And then here it says the number of liters in the fuel tank. Well, that's the variable being represented to represent the number of liters of fuel, but the actual units would be liters. Okay, so this is typically how we write down the title for an axis. You write down the full name of like the quantity that's being represented on that axis, then a comma, then a variable used to represent that quantity, and in brackets we have the units. Okay, so we're going to go ahead and we're going to calculate the slope of this line. So to calculate the slope of this line, we're going to, now by the way, like you can label it like in one of a couple of ways. So if you want, you can label this as like x1, you could label it as y1, you could label it as x2, you could label it as y2. We can also label it with the correct variables. So in this problem right here, it's not x, we're talking about d. So this first point, I could label it as d1. And the second point, this x coordinate, I could label it as d2 because we're talking about distance. And then the y coordinate, it's not y, it's number of liters. So we could label this y coordinate as n1. We could label this as n2. So typically when we try to model like a real life situation, like instead of using the generic variables x and y, which just have an abstract meaning, we actually can turn it into the correct variables being used to model that situation. So if I want to write down the slope formula, so I can calculate slope. So it would be m is equal to, now the standard slope formula would be y2 minus y1 over x2 minus x1. But if we want to, we could replace with the correct variables. So instead of y, we could write down n2 minus n1 divided by d2 minus d1. So this would be equal to, if you look on the graph here, n2 has a value of 40, and it's being measured in units of liters. So you'd have 40 liters. Subtract n1, which is the y coordinate of 0.1, so that'd be minus 50 liters. Divide this by d2 minus d1. So d2 has a value of 120 kilometers. Subtract d1, which has a value of 20 kilometers. Okay, let's pull this up here so I have a bit of space to finish this off. Okay, so 40 minus 50 would be negative 10 liters divided by, and then 120 minus 20 would be 100 kilometers. And we can reduce that fraction. So if we divide the top of the fraction by 10 and the bottom of the fraction by 10, we would get a fraction that reduces to negative 1 over 10. And then the units, again, liters and kilometers are two distinct units. You can't cancel them off. So we just write it down as a fraction. So the slope would be negative 1 over 10 liters per kilometers. Oops. That was supposed to be an M. Okay, that looks more passable now. B, the slope represents the rate of change, which is the change in the amount of fuel tank divided by the change in distance. What are the units used to represent this? Well, we identified it up here. Okay, by calculating the slope actually told me what the units were, and the units were liters per kilometers. C, the amount of fuel in the tank is, well, clearly it's decreasing because you're going to burn that fuel as you drive the vehicle. And you also know it's decreasing because the slope's a negative number. The rate of fuel in the fuel tank is, well, we calculated that. So that's negative 1 over 10 liters per kilometers. So the rate of change in the fuel tank is negative 1 over 10 liters per kilometers. So what that means is for every 10 kilometers that is driven, you're going to consume 1 liter of fuel. Okay, and then negatives means you're going to lose that fuel. Now it also says here, like, the amount of fuel is decreasing. Now by writing that word decreasing, it's accounting for the fact that this is going to be a negative change. So we could say here that this would be negative 1 over 10, or just 1 over 10 liters per kilometer. So again, just the word decreasing would imply we're dealing with the negative, in which case we don't need to write down the negative when we write down the rate of change here. Okay, now D says determine the equation of the line in the form n is equal to md plus b. Okay, that might be a little bit confusing to look at initially, but remember, we're just using different variables to represent the y and the x. So what it's really asking you here is write an equation in the form y is equal to mx plus b. Okay, except instead of using y and x, we're using the variables that correctly model a situation, which is n and d. Okay, so let's see if we can gather this information off the graph here. So we know what the slope is, okay? So the slope, m, is equal to negative 1 over 10. We're not going to write the units down, we write down an equation. Now, the issue is that I don't know what the y-intercept is, okay? So the way I'm going to figure out what the equation is what do we have here? Well, we have the slope, and we actually have 2 points on the graph, okay? So remember, if we have slope and we have any point on the graph, that is the time where it's useful to use the slope point formula. Okay, so what that slope point formula looks like is you have y minus y1 will be equal to m, and then x minus x1. Now what I'm going to do is I'm going to replace y and x with the correct variables in the context of this problem. So instead of y, we're going to write down n for the number of liters of fuel. So we'll write down n minus n1 would be equal to m. And then it's not x, we're dealing with distance, so this would be d minus d1. Okay, let's start to plug numbers in now. Okay, so n is a generic variable that we're not going to do any substitution in for. So we're just going to leave that as n. Now n1 would be what is the y coordinate of point 1. Okay, so we go back up to the graph here. The y coordinate of point 1, which is n1, would be 50. So we're going to subtract 50 in this equation. This would be equal to, okay, the slope, which we determined as -1 over 10. And then d subtract d1 would be the x coordinate of point 1, and that's going to be 20. Okay, so we subtract 20 here. Okay, so now we want to get it into this form. So what I'm going to do is, at this point, is I'm going to just multiply the entire equation by 10 to get rid of this fraction, because the fraction will be annoying to actually like put into the brackets here. So let's just take this whole equation. There's different ways to do it, but this is one way you can, because like what we really need to do now is we just need to isolate for what n is. Okay, let's get rid of that fraction for just a moment. So let's go 10 multiplied by. Okay, now this 10 is going to get multiplied by, we can take the left-hand side of the equation and put it in brackets. And then what we're going to do is we're going to take this 10 and we're going to multiply it by this. And we're also going to multiply it by that. Okay, and let's bring it up here and do this. Okay, so we would have 10 multiplied by n minus 50. So we're going to have to use the distributive property in a moment to do this. And this would be equal to, then you'd have 10 multiplied by everything in the brackets here, or everything on the right-hand side of the equation, I meant, -1 over 10. And you have d minus 20. Okay, so immediately what you notice is that the 10s cancel off. And now we can just apply the distributive property as follows. So the 10 is going to go to this n. It's going to go to the -50. And this -1 is going to go to the d. And it's going to go to the -20. Okay, so this would turn into 10n minus 500 be equal to -1 times d would just be -1d, or just -d. Then -1 times -20 would be +20. Okay, let's try to get n by itself. So we're going to add 500 to both sides of the equation. So add 500. Add 500. And then I'm going to have 10 n would be equal to -d plus 520. To get n by itself, you can divide by 10, divide by 10. Okay, and then my equation, so I've almost got it now. So the 10s cancel. So this would be n would be equal to, okay, write the fraction. So we write this term over the denominator. So that would be negative d over 10. Or you can write down -1. Maybe we could write down as 1. Yeah, negative d over 10 is the same thing as negative 1 over 10 times d, plus the second fraction, 520 over 10. And then just one final step, we're just going to try to reduce or just simplify the equation. So this would then turn into n is equal to negative 1 over 10. Oh, I forgot the d here. There should be a d at this point. Yeah, n is negative 1 over 10d plus 520 over 10. Okay, and then plus 520 divided by 10 would just be 52. So the equation of that line is n is equal to negative 1 over 10 d plus 520. Okay, let's go to a bit more of a complicated example now. So it says Tyrone is paid a base salary per week plus commission for selling electrical appliances. Last week, his sales totaled $3,500, and he earned $620. And this week, he earned $680 for sales of 520. Okay, now if we look at the graph here, what we're doing is we're plotting a graph with earnings on the y-axis, and we're plotting sales on the y-axis. Earnings on the y-axis, sales on the x-axis. So let's just try to identify what our different variables are here. So in this problem, your y variable, we're going to use to represent E, my earnings, and then your x variable, we're going to use to represent S, your sales. Okay, so we're going to take these values and turn them into ordered pairs. Okay, so it says last week his sales were $3,500 and his earnings were 620. So if we write these numbers as an ordered pair, this would be, we could say like, this is 0.1. So we could say that we have, my order pair is like sales, earnings. Okay, sales is my x coordinate, earnings is my y coordinate. So S1 comma E1, therefore the point would be S1, which is the sales were 3,500, and then the earnings, which are 620. Okay, we do the same thing for the second point. So it says this week, so we'll make that the second point. So we'll say that's S2, comma E2. Again, instead of writing down X2, comma Y2, we're just using the variables that actually match up with the physical problem here. Okay, so in the second week, he earned, the sales were 4,250, and then the earnings were 620. Okay, now it says on a grid below, on a grid, plot the ordered pairs to represent this function. Okay, this isn't actually like a really great graph to represent this. So I'm going to create like a little bit of a scale here that I'll just use to model the problem. Okay, so let's look at our x values. Our x values, the biggest x value is 4,250. So I think what I'll do is I'll just make the graph go up to 5,000. So I'll just do like a rough sketch here. So we'll say that, this is 0. This is 1,000. We'll say that's 2,000. We'll say that's 3,000. That's 4,000. And then that's 5,000. Okay, now, unfortunately, I'm not going to be able to write the numbers in here. So this is going to look really weird. So I'm going to say this is 1,000, just because I'm lacking in space. We'll say that this is 2,000. We'll say this is 3,000. We'll say this is 4,000. And then we'll say this is 5,000. Okay, and then on the y-axis, the biggest number we go up to is an earning of 620. So maybe what I'd do is I'd make the y-axis go up to a maximum of 700, and I go up by hundreds. So let's just see if I can draw this. So let's say this is 100. We'll say this is 200. This is 300. This is 400. 500. 600. And this is 700. Okay, so let's attempt to plot these points on the graph now. Okay, so start off at this point. So I'll do this one in red. Okay, so it says when your sales are 3,500, your earnings are 620. Okay, so if I go across here, 3,500 would be halfway between 3,000 and 4,500. And then 620 would be about right here on the graph. Oops, this should be 680, sorry. This number right here, this should be 680. Okay, let's plot that first point. So we have 3,500, 620. So 3,500 is here, and 620 is going to be a point that's about like right there. Okay, now let's try to plot the second point. Now, here's the problem with this. These 2 points are going to be like ridiculously close to each other. So this second point, so we're at sales of 4,250. So that'd be like a quarter of the way in between these two grid lines. But your sales are just barely bigger, okay? Like maybe just a little bit. You're going from like 620 to 680. So it might be like up here, okay? So you have these 2 points on the grid. And it says draw a line segment that just connects these 2 points. Okay, well, there's not a whole lot of space to do this. So actually, let's see if I can do it with a line. So let's try to connect this with a line. Well, the line's going to be so small, I'm not sure if the program's going to let me do it. Okay, so let's do from here to, yeah, it just barely lets me do it. Okay, so that's my line segment. Okay, so you can barely see this on the graph. Okay, B, it says calculate the slope of the line segment joining the ordered pairs. Okay, well, we can definitely do that because we have 2 points. So, okay, so your slope, M, would be equal to, normally you'd write the slope formula as y2 minus y1 over x2 minus x1. But let's change the variables so they're actually in the context of this problem. So in the context of this problem, the y variable is e. So we'd have e2 minus e1 divided by, instead of x, we're looking at sales. So that'd be sales 2 minus sales 1. And then this would be equal to, okay, these are all in values of dollars. So if I wanted to, I could include the unit here. So, sorry, excuse me. The earnings would be 680 for point 2. So this would be 680. Subtract the earnings for point 1 would be 620. And then divide this by the sales. So the sales, 0.2 was 4,250. The sales at 0.1 was 3,500. Okay, so if we calculate this, 680 minus 620 would be $60 difference. And then divide this by 4,250 minus 3,500 would be 750. It's not 750, 7,500. And then we're going to write this down as Actually, what we're going to do is instead of like writing as a fraction, I'm just going to calculate it as a decimal value. So if I calculate it as a decimal value, 60 divided by 600 divided, oh, this should be, yeah, 60 divided by, oh my goodness, this should be 750. Yeah. 420 minus 3500 is 750. I knew I was making a mistake somewhere. Okay, let's just calculate this as a decimal. So 60 divided by 750 would be a number that is 0.08. Okay, now it says identify what the slope of the graph represents. Well, the slope of the graph is a represent. It's showing you what are your earnings per sales. So one way to think of the slope here is you could write down 0.08 divided by 1. So what's happening is this is how much he earns per dollar of sales. So what he's doing right here is 0.08 of a dollar would just be 8 cents. So for every dollar earned, so I could say it's the amount earned per dollar of sales. Okay, so that's that slope of 0.08 represents. It's telling you how much does he earn in dollars per dollar of sales. So that's 8 cents per dollar, which is like not a whole lot. Okay, D, state as a percent the rate of commission this person is paid. Well, this is like the amount of like commission he's making as a decimal. So it's $0.08 per in earnings per dollars of sales. If I want to convert this into a percentage, all I need to do is multiply the decimal by 100. And then what we get here is we get 8%. 8% is the rate of the commission. Okay, now E says calculate his weekly base salary. Okay, so what's happening here is he gets a base salary regardless of how much sales he makes. And then once he starts making sales, he gets this like really pitiful low amount of like commission, although maybe 8% commission is good. I couldn't really say, I've never really worked in sales. Okay, but we want to figure out what the base salary is. Okay, now if we go back to the graph here, we can identify what the base salary is off the graph. Okay, the base salary is your salary with no sales, or I'll say salary before any sales. Okay, so the salary before any sales would actually be the y-intercept of the graph. Now, we can actually use this really tiny line segment to like approximate what the y-intercept would be. So I'm going to take another line, and then if I just take this line segment and I kind of just extrapolate it down to the y-axis, you would have it look something like this. Okay, so that's what we're trying to figure out. We're trying to figure out like where does this guy hit the y-axis at, okay? And that's going to be his base salary because that's his base salary before any sales have actually occurred. So we need a way to figure out what the y-intercept is. Okay, so the way we're going to do this is what we know is we know the slope, which is 0.08, and we know 2 points on the graph. So the most effective equation to start off with would be to use the slope point form. And then from the slope point form, we can then turn the equation into y equals mx plus b and figure out what the y-intercept is. Okay, so let's start off the slope point formula. So my slope point formula is y minus y1 is equal to m and then x minus x1. But let's replace it with the variables in the context of this problem. So it's not y, it's earnings e. So this would be e minus e1 would be equal to m. And then it's not x, it's going to be s. So you'd have s minus s1. Okay, now let's start to like sub numbers into this equation. Okay, so we have e minus e1 is the x is the y coordinate of point 1, so that's 620. So we're going to go e minus 620 is equal to the slope, which is 0.08, and then multiply by, instead of x, we're going to use s, the sales. So we have s minus s1. So the sales 1 would be 3,500. And then now let's use the distributive property. So I'm going to take this 0.08, I'm going to apply it to the s, and I'm going to apply it to the 3,500. Okay, so this would then turn into e minus 620 would be equal to 0.08 times s would just be 0.08 s. And then 0.08 times 3,500, well, you can plug that into your calculator and get it. And that would be a number that should be 280. So we're going to subtract 280. Okay, to get it in y equals mx plus b format, just add 620 to both sides of the equation. Add 620. We're going to add 620. Okay, and then we'll have my equation, which is then going to be e is equal to 0.08 s plus 340. Okay, so again, this is now in the form y is equal to mx plus b. And we said the y-intercept is the base salary. So I can just say here the base salary. Is equal to the y-intercept, which is $340. Now, if you look back at the graph, I didn't quite pinpoint that. So on my graph, and again, keep in mind, this is a rough sketch. I didn't use a ruler to space these grid lines out, and I really approximated where these points would be. So I ended up getting a base salary between 400 and 500, but that's just because I just didn't do an accurate job of drawing the graph. I just did the graph to show you what the base salary actually represents, which is it's the amount of money you make before you even make a single sale. Okay, now F says, how does the answer to E relate to the graph? Well, we already identified that. So the answer to E is what's the base salary? Okay, well, and we already clarified that the base salary is your y-intercept. Or if you want to write it in terms of the correct variable, you could also say it's the e-intercept of the graph, because the variable e is being used to represent the y-axis. Okay, write the equation in the form E equals ms plus b. Hey, we already did that, okay? So that was done in part E. Now it says 2 weeks ago, Tyrone earned $586 calculated sales for the week. Okay, so we're going to use our equation to do this. So let's write down that equation. So the equation was E is equal to 0.08 times S plus 340. Okay, now he says he earned $486. So what I'm going to do is I'm going to use the equation. In the place of E, I'm going to plug in the amount of earnings he made, and then we're going to isolate the equation for S and figure out what the sales were. So now that we have an equation, we can use the equation to interpolate or to extrapolate, which is exactly what we're going to do in this problem. Okay, so instead of E, we have 486 would be equal to 0.08 multiplied by S plus 340. Okay, let's get S by itself. So we're going to subtract 340 from both sides of the equation. Subtract 340, subtract 340. And then what I would get is, this would be 146. Would be equal to 0.08 times S. Get S by itself, so we're going to divide both sides of the equation by 0.08. Divide by 0.08. These 0.08s are going to cancel off. And then we get our sales for that week. And we're going to write down a unit now in dollars. So 146 divided by 0.08 would be 1,825. Okay, so that's one example of using slope as a rate of change. So we're using like the commission they make as a rate of change to identify like how much a person actually earns. Now we kind of started off with this actually. We actually in the first what was it called? The first the part one of like the rate of change started off with. We looked at a graph of like distance and time, and we can actually use that to calculate. So we calculated the rate of change in that part, like how much distance is covered in a certain amount of time. It turns out that's a definition of what average speed is. Average speed represents how much your distance changes by in a certain amount of time. Okay, but let's kind of like work with this in this problem. So it says John is taking part in a long distance race. After 3 hours, he has traveled 270 kilometers. And after 6 hours, he has traveled 630 kilometers. So part A is I want to plot the ordered pairs on the graph. Okay, so we first of all need to identify what is the output variable and what's the input variable, like what is dependent on what. Well, the distance you travel depends on the time. So the time is going to be your input variable or your manipulated variable. So time is going to represent the x-axis. And the distance is your output because your distance depends on how long you've actually been driving for. Okay, let's try to set up a scale here. So what I know is it says, we can write down some ordered pairs actually. So this first ordered pair, we can write down in the form T. T is the variable I want to write down first. Okay, so T1, comma D1. And this would be, okay, time 1 is 3 hours, traveled 270 kilometers. And then over here, the second point would be time 2, D2. And this would be, after 6 hours of driving, they've gone 630 kilometers. Okay, so we need to create a scale first of all. So let's look at it like our biggest x value or biggest t value. It's 6. So I think what I'm going to do here is I'll start the graph at 0, make every second grid line go up by a 1. So we'll go up by a 1, 2, 3, 4, 5, 6, and then up to 7. Our largest distance value is going to be 630. So I think what I'll do is I'll make every second grid line go up by 100. So this one would be 100. This one would be 200. This one would be 300. This one would be 400. This one would be 500. And this one would be 600. All right, so let's plot these points on the graph. So when we're at a time of 3, where our distance traveled is going to be 270. So that's going to be between this grid line and the 300 grid lines, maybe something about like right here. And then when we've traveled 6 hours, we're up at 630 kilometers traveled. So that's going to be above 600 and 600 here. So maybe at like this point. Okay, now it says calculate the slope of the line segment that joins those two ordered pairs. Okay, so let's get a line segment to connect these dots. So that would be a line segment that just goes from here to there. Now we can calculate the slope using the slope equation because we have 2 points. So let's go and calculate that. So this would be your slope is equal to y2 minus y1 over x2 minus x1. But we can change it to the correct variables. So instead of y, it's d. So you have d2 minus d1 divided by t2 minus t1. Okay, this would be equal to d2 has a value of, let's plug the units in too, so 630 kilometers minus d1, which is 270 kilometers. Divide this by T2 minus T1. So T2 is 6 hours minus T1, which is 3 hours. And then this would give me 630 minus 270 would be 360 kilometers. Divided by 6 minus 3 is 3 hours. Okay, now to calculate the slope, it's divided in 2 parts. We'll divide the numbers first. So 360 divided by 3 hours would be 120. And the units, they're 2 distinct units, can't cancel them off. So just write them as a fraction. So it would be 120 kilometers per hour. Now it says the slope of the line segment represents a rate of change, okay? Because what this number means is for every hour traveled, you would cover 120 kilometers in distance. The rate of change is the change in distance over the change in time. Now, there is a name for this quantity. When you look at change in distance divided by change in time, that's equal to what we call average speed. When you take Science 10, you'll learn about this equation. So basically, if you want to calculate the average speed of an object, so we can say like V average, so VAVE, it's equal to your change in distance. So when you talk about a quantity that changes, we use a little triangle symbol. So triangle symbol means the quantity is changing. So you have your change in distance divided by change in time. It's like one of the first equations you would learn in like the physics unit when you try to describe motion. So your average speed is your change in distance over change in time. And it turns out that the slope of a distance time graph represents that quantity. Okay, so state the average speed of the car from 3 hours to 6 hours using the appropriate units. Well, we've already identified that. So your average speed here was equal to the slope, which is equal to 120 kilometers per hour. Now D, it says on the grid, plot the point 0, 0. Okay, sure, I'll plot a point at the origin. So right here. And it says, determine the average speed of the car during the first 3 hours of the race. Okay, so what's happening here is they're not moving at the same speed the entire time. So for the first 3 hours, they're moving at like one specific speed. And then from 3 to 6 hours, they're moving at 120 kilometers per hour. So what I'm going to do is I'll just illustrate this graph on the graph by just connecting another line segment. So let's go to a line here, and then we'll make it red this time. Okay, and I'm going to make a line go from, well, I was going to attempt to make a line go. Let's try it again. A line go from here to there. Now, it's a little bit subtle, but if you look at the actual line segments, they don't quite have the same slope. The slope of this blue line is actually a little bit steeper than the slope of the red line. So because the slope represents the speed, we're actually going to get a lower speed from going from 0 to 3 hours. But we're going to go ahead and we're going to confirm this. Okay, so the way we could do this is we're going to use the slope formula again, except we're going to do it with different points. So this time around, the points we're going to use, and I'll just illustrate this with a different color, is our starting point is going to be this one. Okay, so that's going to be 0, 0. And then our end point of this line segment is going to be this point. And that point was 3, 270. Okay, so we're going to treat this one as, I'll say this one is x1, y1. We're going to treat this one as x2, y2. Okay, so let's go ahead and calculate it now. Okay, so your slope would be equal to, and again, you can use whatever variables you want here. So I suppose it's probably more accurate to use d2 and d1. So we'll do d2 minus d1 over t2 minus t1. We're just using different points to represent 1 and 2. So point 1 is now this point at the origin, and point 2 is now going to be that point. So this would then be d2 minus d1 would be 270 kilometers. Subtract d1, which is 0, divided by t2, which is 3 hours, minus 0. So this is going to give you, I mean, subtracting 0 doesn't do anything, 270 kilometers divided by 3 hours. So because your slope is your average speed, then I'd have my average speed for these first 3 hours would then be 270 divided by 3 is 90. And then that would be kilometers divided by hours. Okay, so for the first 3 hours, they're moving slower, and then the next 3 hours, they're moving faster. And you can kind of see this because the slope is getting larger. A larger slope means that your average speed is a little bit bigger. Okay, E says, by looking at the grid and without doing any calculations, how can we tell that the average speed during the first 3 hours was less than the average speed during the last ones? Well, I just mentioned that. It's about the slope. I'll say since M, which is your slope, is your average speed, the car moves faster from 3 hours to 6 hours because the slope is steeper. Okay, and that's it. So Got some applications here. Slope is a rate of change. I mean, this is actually like a really important thing that if you choose to take Physics 20, that we deal with a lot, like calculating slope of lines and trying to figure out what the slope of a line segment represents in terms of a rate of change. But you can practice this right now by doing numbers, just a few of them, 1, 4, 6, and 7. And then I will talk to you in the next unit.